So, conductivity. Conductivity is essentially where we can take electricity and we can take it from one thing to another. So if we think about electricity in terms of our wiring, that's conductive. So wires are conductive because they allow electricity to move from one end to the other. Now, why is wire conductive? Well, wire is a metal. And metals particularly are able to do this, but essentially what needs to happen is that whatever your material is that you want to conduct electricity, it must have free moving charged particles. So for current to move, for electricity to move, it needs to move through moving charged particles. The particles need to be charged and they need to be moving. In metals, the electrons are free to move. So in metals, they have different bonding. They don't have covalent bonding. They have bonding in which the molecules all sit within sort of a lattice. They all sit in a specific spot. And then these electrons can kind of just freely move in between them and just hold them together. But they can move where they want. They can kind of move around and go wherever they want. So they can do like this. They've got all of these metal molecules, and all of these metal molecules will be a positive charge. And these electrons, which are negative charge, can just go wherever they want. They can go, all right, I want to go here, I want to go back here, I want to go over here, oh, I might go up here, I might come back down here. They can go wherever they want. They can kind of just go in between like that. They can do whatever they want. They have no rules, so they can move. So when you apply a current to this, so say this is a wire, and you apply a current up here, and you push it this way, essentially what happens is it'll hit an electron, and then this electron will hit this electron, and then this one, and then this one, and then this one. And essentially they'll move along. This one might actually travel a little bit, then it'll hit this one. And essentially what this charge will do is it'll move along electrons to the other end of the wire. And that is how we get something to be conductive. Now, that's for metals. A lot of other substances don't have free moving molecules. If you're a covalent molecule, you're not going to have free moving electrons because those electrons are pulled into the shell and they're not allowed to move. So what about if they were a liquid? Well, a lot of substances, when you make them into a liquid, actually just form ions. So they form ions. They remove electrons to get their outer shell being filled, and they form ions. And those ions are free moving because they're in a liquid. If something's in a liquid, they're not locked in. They can do what they want. They can move around. So a lot of the time, substances as a solid that don't conduct, when you make them into a liquid, may actually conduct if they have ions. So it's really important to understand that sort of difference. Understand that conductivity is all about free moving electrons. So, metallic bonding. So metals, now we're going to go through metals. We're going to go through everything metals just very quickly. So metals readily form cations, and so they're positively charged ions when they lose electrons to gain a full outer shell. These freed negatively charged electrons form a sea of delocalized electrons. That is the wording you need to use. So I mentioned before that those electrons are free and they can move wherever they want. We refer to that as a sea of delocalized electrons. Now these move throughout the metal structure. They move in between all of those individual metal ions. And this allows for the conductivity of electricity. Electrostatic forces of attraction between the positive cations and the negative electrons holds the metal together. So those electrons moving in between all those atoms keeps it together. And use these key terms to explain the properties of metal to gain more marks. So if we talk about metals, they have a high melting and boiling point. This is because they have strong forces between molecules. They're usually a solid at room temperature. For example, your laptop, it's not a liquid at room temperature. It's probably made of metal. That's because it's got strong forces between molecules. It's got really strong intermolecular bonds. Some metals can be hard but brittle. This is more about ionic substances, but some metals are generally hard and can be brittle if they are alloys. So they've been made in very specific ways. So they would still have strong forces between molecules. This case here, they actually do. This is about ionic substances. And then if we talk about liquid and so forth. So this is where we start to move into our ionic substances, which we refer to as compounds. So, this is just more on our metals. As you can see here, our metals all fall in here. These are all our metals over here. Moving on. Here's our other things about metals. So, metallic substances. So, Metallic substances also have these really cool things here. So they have these 5 properties that are a little bit different for them. So obviously conductivity, we just talked about. We don't need to talk about that. Strength, we've talked about. We don't need to go through that. Melting point, we've also talked about. We don't need to worry. But they have these 2 here, which we haven't discussed so far. So metals have these 2 really cool properties. Some metals can be quite brittle. You hit it and it smashes. But most metals are actually what we call malleable. And that's where we refer to metals being able to be hammered and bent. So think about those medieval movies where they make swords and they make anything that is like metal in, like just like metal armor or like a metal shield. Notice how they heat it and then they're banging it with a hammer. So you see those things in movies. That's essentially where a metal is malleable. That is what malleable or malleability in metal is. So as you heat it up, you can bend it and you can twist it and you can do what you want with it and it'll stay together. This is also what we refer to as ductile. Oops, I didn't mean to draw right through it. So ductile refers to being able to stretch something into wire. And so metal can be stretched into wire. We know that because we have metal wiring. And so ductility and malleability are 2 words that you need to know in terms of metal properties. The other thing is lustre. So the ability to polish, to shine, is found in metallic substances. So you know how you can get a metal, and if you give it a really good polish, you can get it really shiny. That's lustre. You can't do that with everything. You can't do that with plastic. You can't go and polish plastic and it become shiny. You can only do that with really metals. And then there's this really cool concept. So this is also becoming super high here. So there's this really cool concept that's been added to your study designs. This is the first time it's ever really been discussed as a part of VCE. And this topic is circular economy. So if we think about recycling and we think about what our knowledge of recycling is, our knowledge of recycling is we put it in a recycling bin, it gets taken to a recycling site, and then we assume that what happens is it gets recycled, it gets broken down into the elements and the materials that it already was, and then it gets sent off and gets reused. That doesn't always happen. Most of the time, recycling tips are what we refer to as a linear economy. What is a linear economy? A linear economy is where we produce something. So, for example, we'll say copper wiring. We produce copper wiring. We utilize copper wiring in a device. Maybe it's a laptop, maybe it's a phone, whatever it is, we use the copper wiring within the device. Eventually that device becomes, unusable. It's not needed anymore, or it just breaks or whatever it is. We get rid of that device. Essentially what we do is we go to recycle it, but what we find is that we have no use for the copper wiring, or we don't have the facilities to properly recycle the copper wiring. Essentially what happens is it goes to landfill, or we break it down appropriately and we get rid of it. We don't reuse that material. Circular economy, on the other hand, is where we have specific sites, we have specific places where we can destroy something, or we can take a metal, for example, like copper wiring, and we take the copper wiring to that site and we say, I've got copper wiring, go ahead and reuse it. And essentially what they do is they take the copper wiring and they don't really need to do much with it. They can potentially melt it back down into copper, but most of the time they'll just take that copper wiring out and they'll put it in something else and they'll use it again. That is circular economy. So essentially the steps of circular economy are these. In this case here, I've used copper mining as sort of the main example. So you mine the copper, you extract the pure copper, you form the wiring, you utilize the wiring in a product, let's say such as power lines, use the power lines until they need replacing, upgrading, you recycle that copper wiring back into pure copper extract, and then you utilize that copper to make a new product. It might be new wiring, or then something else that then utilizes that product again. So these are the steps of circular economy. Now, I think what's really important here is these are really sort of 6 steps. These 2 are sort of 1. You don't really think of mining, you think of just obtaining copper. So think of this as obtaining copper. So these 2 steps are obtaining copper. And so you obtain copper here, and then these are the next 5 steps. So you form the product. So if we think about this as a general term, you obtain the metal. Step 1. Step 2, you form the product using the metal. Step 3, you utilize the product. Step 4, you remove the product for recycling. Step 5, you recycle the product by the metal by melting back down into its pure form or sending to a relevant location for reuse. 7 or 6, the last step, you utilize that product, you utilize that material in a new product. So essentially, this one here is just obtaining. Don't worry about these other steps. But this is sort of what you need to think about. So these are the 6 steps. So mine, refine, produce, utilize, recycle, reprocess. So these are a better way of sort of wording it. I think I went through and thought of some good words, and I went through and picked out things that sort of rolled off the tongue well, because the way, as you could hear, when I was trying to do it off the top of my head, it took a while. So I went about and sort of made these into something that sort of reads well. So mine, refine, produce, utilize, recycle, reprocess. So think about those as your 6 steps of metal circular economy. So mine, refine, produce, utilize, recycle, reprocess. And you can utilize this in sort of a circle. So if this is your mine, this would then be refine, this would then be produce, utilize, I always forget the last one, recycle, and then repurpose or reprocess. So these are your 6 steps. And notice how 1 doesn't actually go back into the circle. Why is that? Because you can't re-mine metal. You've already mined the metal, so I'm not going to mine it again. So when I reprocess it, I may refine it again, and then I'm going to produce my product, and then I'm going to utilize it again. This second step might get skipped again, but it's still within the cycle because you can kind of put it within number 6 if you need to. So here's a sort of practice question. I want you to have a think about how you would go about answering this if this were to be like a SAT question or an exam question. You're given a question that says, zinc coating is used on the outside of ship hulls to ensure the steel structure does not rust. This breakthrough has allowed ships to last longer and for steel to be easily recycled into new ships. Produce a 6-step cycle for steel utilized in ships. Now, I hate that it's gone to the American spelling, that should be an S. So I want everyone to take a minute. I want you all to sort of sit back for a minute and just think, what would I say for each of these things? I don't want you to write it down like this would probably be a 3 or 4 mark question. I don't want you to go ahead and write that down. We're too early on in the year for that. But what I want you to do is just take a step back and think, what would be my 6 steps here? So have a think about that. How many slides do you have left? All right, so hopefully you had a quick think. So these are what I would sort of think of. So I would think, first of all, mine the steel. So you're going to mine the pure steel. You're then going to, so once you've mined that steel, you're going to go ahead and refine that down into the pure steel that's necessary for the production of the ships. You're then going to produce the product. So you're going to produce the ship. So first of all, I'm going to mine the steel. Then I'm going to refine that steel into steel necessary for ship making, send it off to the ship company. The ship company is then going to produce a ship. The ship's then going to be utilized. It's going to be used maybe, in transport of materials or something like that. So you utilize the ship. The ship eventually needs upgrading because over time, parts of the ship have begun to rust. 6, you're going to reprocess that steel. So you're going to remove the rusted steel. You're going to get all of the steel that's in good condition and you're going to melt it back down. You're going to send that melted back down steel back off to be refined again. and then you're going to send that new refined steel, which may be a little bit less than what you started off with, but it's mostly what you had, back to the ship company, which will make more ships. And that is what your 6-step process is. So that's how I think about that process there. And that's a really important concept to understand, how we sort of